In this video, we're going to talk about percents. Specifically, we'll be looking at examples involving discounts. So let's compare the following two problems. Example A says that a $1,700 television is on sale for 15% off. What is the sale price? And example B says a television is on sale for 15% off. The sale price is $1,870. What is the original price of the TV? Now, in both of these instances, we have a television set, and it's on sale for 15% off. In the first example, our original television price is given, but not the sale price. In the second example, our sale price is given, but not the original price. That makes these two problems just a little different. And in fact, it has a big difference in the way that we solve them. Before I show you how to solve these problems my way, I want to preface it by saying that you may be able to solve these an entirely different way, and that's okay. Everybody's brain thinks a little differently. I'm going to try and explain it from my perspective, or one way of looking at the problems. But don't ever think that just because you're not doing it the way I'm doing it, you're doing it wrong. As long as we all get the same answers at the end, that's what's most important. What I'm going to begin with is I'm going to start with kind of a bigger overview idea. So let me draw a picture because I'm a big picture girl. So I have a television and it's priced, right? It has a price on it. So it has an original price. And what I'm going to do is I'm going to take 15% off that price, and I'm going to come up with a new price or a sale price. Now, when I apply that 15% discount, am I applying it to my original price or my sale price? Well, we take it off our original price, right? We apply the 15% discount to the original price. In other words, we're going to take a percent of the original price, and thinking back to our percent equation, we always take a percent of our base. That means whatever the original price is for the television set in any example is going to be our base. We will be taking a percentage of our base, and we're going to wind up with our sale price, and that makes our sale price from our percent equation the amount. The only thing that's missing is we take the percent times the base, right? So the one piece that I'm missing right now is that percent. We take a percent of a base. Now, one way to approach this problem is to take 15%, multiply it times the television price. That gives us a discount, and then subtract that discount from the $1,700 and get our sale price. And that's a perfectly fine way to do it. But I want to see if I can't be a little slick and do it in one line. Namely, let's think this through here. If I'm discounting my original price by 15%, what percentage of the original amount is going to be my sale price? Well, let me think. So the original price is 100% of the price, right? And if I take off a 15% discount, that tells me that I have 85% left over. Or in other words, the sale price is actually 85% of my original price. 85% of my original price. So I could use 85% as the percent in this percent equation. And that would tell me that I have my 85% of my base equals my amount. And let's put everything together. Let's write our equation, shall we? Okay, the base is the original price, and that's $1,700. I'm going to take 1,700 times my percent, and my percent is 85% or 0.85, and that's going to equal my sale price. But for this particular problem, I don't know what that sale price is, and so that's going to be X. So the percent equation that would solve this example would be 1,700 times 0.85 equals X. I'm going to pull out my calculator. I'm going to type in 1,700 times 0.85, and it's going to give me the answer of 1,445. That's the value of X, or in other words, that's the value of my sale price. A television that's $1,700 on sale for 15% off is going to cost us $1,445. Did you get that too? Let's take a look at example B. A television is on sale for 15% off. The sale price is $1,870. What is the original price of the TV? So I'm going to write down that percent equation again, right? The percent times the base, or if you like, the base times the percent. Either way, they're interchangeable. So the percent of the base, percent times the base equals the amount. That's our percent equation. And for this particular problem, remember, we're going to always take the percent of the original price. So my original price is always my base. Now, in this problem, I don't know what that original price is, so that's X. My percent, I'm going to steal and use that percentage from last time. If the TV is 15% off, that means that my sale price is going to be 85% of the original price, so I'm going to put 85 in for my percentage. And what is that amount? That amount is given to us. The sale price is given to us. That's $1,870. And let me rewrite this equation. On the left side, I have X times 85%, or if I like, 0.85 times X equals 1,870. I'm going to divide both sides of my equation by 0.85. That gives us that X is 1,870 divided by 0.85. Pull out your calculator. Divide those two numbers and you should get 2,200. Or in other words, the base, the original price of the TV was $2,200. Let's take a look at one more problem that involves the percent equation and a discount. Suppose you go shopping for a new bed. The mattress you like happens to be on sale for $2,650. Its original price is $3,200. What percent of the original price will you save if you purchase this mattress? Well, I like to start again with the percent equation, which is the percent of the base, or the percent times the base, equals the amount. And it's obvious from the discussion, from what we see here, that what's missing is our percent, right? So that's going to be our X. We don't know what our percent is. And we take a percent of our base. But remember, when we're talking about discounts, our base is going to be our original price. So the original price is $3,200, and that's what we're going to be taking a percentage of. So percent times 3,200 equals our amount. That's our sale price, which is $2,650. And now I'm set to solve for X, or our percent. So let's take and divide. Whoa, slow down, Tina. I got a little ahead of ourselves. So what we're going to do is we're actually going to solve this equation. So on the left side, I'm going to rewrite it as 3,200 times X equals 2,650. And I'm going to divide both sides by 3,200 to set X by itself. And that's going to give me, pulling out my calculator, 2,650 divided by 3,200 gives us approximately 0.828125. Oh, this is a long decimal, isn't it? Okay. And so what approximate percent, well, we have to move our decimal 2 places to the right, right? So that tells me that our percent is approximately 82.81%. If the problem doesn't specifically say round to the nearest whole percent or 1 decimal point, if it doesn't tell you, I'm always safe and I like to go to 2, but generally in my open math, your problems will tell you what to round to, okay? But that tells us that the percent of the original price, 82.81%. Now my question is this how much we're saving? Or what exactly is 82.81%? Well, the way that we set this problem up is we set it up so that we were looking at 2,650 being what percent of 3,200? In other words, this isn't our discount. This isn't how much we're going to save. 2,650 is 82.81% of our original price. So to calculate our discount, we want to take 100% and subtract off from it that amount, 82.81%. And if we pull out our calculator again and take 100 minus 82.81, that gives me a value of 17.19%. This here represents the discount. How much what was our mattress discounted by? It was discounted by 17.19%. That's what made the sale price, $2,650, be 82.81% of the original price. That's our little discussion on discounts and percents. If you have any questions at all, please don't hesitate to reach out to me. Good luck as you're doing your homework.